In this lesson, we will consider linear correlation. We often want to know if there's a relationship between two quantitative variables. When a variable like temperature goes up, then does the other variable, like the growth of plants, go up or down? In this case, we are asking the question, if we increase the temperature like 60 degrees, 70 degrees, 80 degrees, 90 degrees, do our plants grow faster? We say that there's a positive association or positive correlation. When one variable goes up, the second variable goes up as well. And then we say that there's a negative association or negative correlation when one variable goes down and the other variable goes down also. Think about the line y equals x. Notice that when x gets larger, y gets larger at an equal rate. Notice in the line y equals x, when 1 is 1, 2 is 2, 3 is 3, and so on, there's a perfect association between the variables. We say there's a positive linear relationship between the variables when the pattern of the points goes up in this way. Examples include drinking energy drinks and getting to sleep, eating candy bars and weight gain, and the number of hours you study for this class and the grade you earn in the course. If there's a negative correlation like distance and sound, the graph goes the opposite way. Notice here there's a negative relationship between the two variables, like the miles you run per day and your weight. All values for the correlation R are between -1 and 1 inclusive. If there is no relationship between the two variables, like for example how tall you are and the grade you get in the class, then the correlation is 0. There's no correlation. Stronger correlations have values closer to 1 and -1. A somewhat positive correlation is the score you got on the placement test to get into this class and your final grade in this class. But that's not a strong correlation because there are some people who don't do well in the placement test and do very well in the class, all dependent upon their motivation. The correlation between distance and sound has a negative association and is close to -1. There's a negative relationship between distance and sound. The farther I get away from you, the less you can hear. So as distance increases, sound decreases. We say that a correlation of 1 or -1 is perfect because it forms a straight line. Also note that similar to the mean and standard deviation, the correlation coefficient is strongly affected by outliers. Outliers can misrepresent the entire set of data points. However, there are always students who do really well in the course and spend no hours studying, and there's always someone who spends a lot of hours studying but doesn't do well. Here's a relationship between the number of hours a student studies for this class and the final grade in the class. Notice here that the relationship is pretty strong, but there are always some people who studied a lot but earned a low grade, and those who don't study very much but ace the class. Those students are truly outliers. Another good example of correlation is the number of energy drinks consumed after dinner and the time it takes to get to sleep. The correlation again is positive, but this time the correlation is about 0.82. There are many ways to compute the linear correlation. One way is to input the points x and y into a calculator, or Excel, or some other software program. In order to do this in Excel, use the first two columns A and B and input the x and y values. Sometimes it's helpful to see the data on a scatter plot first, so that you have some idea if the correlation is positive or negative. To do this, click on the word Insert and then click on Scatter. That will give you the scatter plot. To get the correlation, select an empty cell and click on it. Go up to the Function button and then the Insert Function drop-down menu. Search for the function by typing in the word correlation. Click on the word Go at the top and then select the word Corel, and then click OK. Then to insert the data, in array 1, put the data from the x values by selecting the x values you put in before for x, and in array 2, select the data from the y values you put in before for y. Click OK, and that will give you the correlation in the cell you chose at the start. Although the formula for the correlation coefficient looks hard, in fact the hardest part is adding up the numbers correctly. Let's say we pick these 5 points, 3, 5, 0, 1, 2, 4, 5, 7, and 1, 3, and make a chart with the x's in one column and the y's in the other. If we want to compute the correlation coefficient by hand, then we need to know these values. We need to know the number of points, in this case 1, 2, 3, 4, 5 points. The sigma means to add, summation of x means to add the x values, summation of x squared means to add the squares of the x values, summation of xy means to add the product of x and y. So here's our data. There are 1, 2, 3, 4, 5 points. We need the squares of the x squared, which is 9, 0, 4, 25, and 1. We need a column for y squared and xy. Y squared is 25. Here, this is 1. 4 squared is 16. 7 squared is 49. 3 squared is 9. And x times y, this is 15. 0 times 1 is 0. 2 times 4 is 8. 5 times 7 is 35. And 1 times 3 is 3. And we want to add each of these columns. So we find the sum of the x squared values, the sum of the x values, the sum of the y values, the sum of the y squared values, and the sum of the xy values. Here's our original paired data, and here's our chart, x, y, and from the other chart we had x squared, y squared, xy, and we added each of these columns. This is the formula for correlation coefficient. It looks really complex, but in fact the hardest part is just substituting the values in and following through with order of operations. But let's see how that looks. We have R equals I'm going to put all of these parentheses here, square root, and then input the values. N is the number of scores, 1, 2, 3, 4, 5. Summation of xy is 61. The summation of x is 11. Summation of y is 20. N, the number of scores, is 5. The summation of x squared is 39. The summation of x is 11. N is 5. The summation of y squared is 100. The summation of y is 20. So 5 times 61 is 305. 11 times 20 is 220. 5 times 39 minus 11 squared is 74. 5 times 100 minus 20 squared is 100. And then we subtract these to get 85. We take the square root of 74 and the square root of 100. We multiply those to get 86.02325. We divide this and we get 0.988 as our correlation. When we graph these points, the result we get is very close to a line, which is what we would expect. If we have a correlation of 0.988, that's very close to 1. So we expect a line that is very close to a straight line. If we take the 5 points here and we plot those points, notice how close to a straight line we have. So we conclude that there's a strong relationship between x and y. We can actually find the equation of a line that goes through the center of this data. This is called the regression line. Using this, we can get a fairly accurate prediction of the value y for a given value of x. However, there will always be some error because the results are random and there are other factors affecting the outcome y. We sometimes find r squared, which is the proportion of the variation in y that is explained by the linear relationship between x and y. Let's take the correlation coefficient we just found, which is 0.988. Let's say we want to find the percent of variation. We square this value. We get r squared equal to 0.976. We can conclude from this that 0.976, or about 98% of the variation, can be explained by the linear relationship, or about 2% of the variation cannot be explained by the relationship between these two variables. Finally, a statement you should remember is correlation does not imply causation. This means that just because we got a correlation between the two variables, It does not mean that one caused the other. For example, if I found a correlation between the numbers of pencils a student brings to class and their final grade, be careful. Students should not bring more pencils to class and assume that this will improve their grade. That is all for now for correlation. Try a few examples and see if you can find a relationship between two variables. But be careful. Don't assume that just because you find a correlation, that it implies causation.